All right, so this video is going to be the homework hints for chapter 4 for the course. This probability chapter here is really a deep dive into many different probability topics. And so I'm going to spend some time doing a problem from each section. Some of the sections I'm going to actually do 2 homework problems to give you some hints on each section here, because each section has a different probability rule or rules that you're using. So in section 4.1, the question that I thought would be really good to go over was 410. And that's because the wording of the question is a little bit confusing, or can be. So when you withdraw the $40 from the ATM is going to do one of 2 things, and one of 2 things only. It's either going to give you 2 $20 bills, or it's going to give you 4 $10 bills. Okay, and then 2 people come up and withdraw from the ATM. And so if we want to think about the number of outcomes or the number of possibilities that could happen here, let's look at person number 1 first. So person number 1, 2 things could happen, right? They could either get the $20 bills, the 2 $20 bills, or they could get the 2 $10 bills. Person number 2 also has the same 2 outcomes. So if the first person got the 20s, then the second person, well, they could either get the 20s or the 10s. And if the first person got the 10s, well, then they could get the 20s or the 10s. And so that's going to help you, creating that tree diagram is going to help you kind of figure out all the different possible outcomes that could happen, because person 1 and person 2, they're going to be chosen kind of differently here, okay? Now, the next part of this question is compound or simple. On the questions, so like on problem A, or part A of this problem, it's asking what's the probability, or what are the outcomes if exactly 1 customer receives a $20 bill. So if only 1 receives the $20 bill, then that means, well, if it's this first one, then the second person must have received the 10. So that's one of the outcomes. And if the first person received the 10, then if exactly 1 person got the $20 outcome, then it would have to be that one. And because there's 2 different outcomes here that are possible, we're going to call that compound. Okay, if there's only 1 outcome, we're going to call that a simple outcome. But if there's more than 1 outcome possible, then we're going to call that compound. All right, so that's section 4.1. Let's look at section 4.2. Questions. And for this one, I want to do 4.24. All right, so in this problem for 4.24, it tells us that there are 300 adults. So I'm going to go ahead and say, like, okay, my total, so N is 300. And then it tells us some things about ice cream here. So 123 like chocolate and 84 like vanilla. Now, the first thing that I look at right off the bat is this data everybody? Okay, and so I'm going to do that by adding these 2 values together. And so if we add 123 and 84, I only get 207. So there's 93 people, because if I have a total of 300, there's 93 people that I really don't know what their response is based on the data that they gave me in this problem. Okay, and so that's going to be really helpful in answering the questions on this part here, is because there's this like unknown response quantity here of the 93. So on part A, if I just want to figure out the proportion or the probability that likes chocolate, I'm just going to look at the number of people that like chocolate over 300, similar for B. And then this hint here that I'm giving you about the 93 that we don't know is going to help you answer the final question about why those probabilities for A and for B don't add up to 1.0 or 100%. All right, on 4.3, I am going to have us look at problem 434 together here. So 4.3, we're going to look at problem 4.34. And I'm going to go ahead and copy this table down here so you guys can see it on the screen. Okay, so we have males and females, and then we have yes, they have used the internet, and no, they have not used the internet to shop. And I'm pretty sure this data is old because not a lot of people in this sample based on this have shopped on the internet, and I think that it should be much higher than that. But in the problem, it says that there's 2,000 randomly selected adults who are in this study. So I'm going to add kind of in this corner here a 2,000 because that's like the total. And something that they don't give us in this problem that I think would be extremely helpful are the margin totals. So if I add each column, so if I add yes and I add no, I get that 800 people total out of the 2,000 have shopped online, and 1,200 have not. And that's what I was saying earlier, that I think this proportion is a little bit off now. I think the data in the book is probably a little bit old because I'm sure that this would be switched in real life. And then if I look at also the total of males and I add across, there would be 1,200 males and 800 females. So there's more males than females in my data here, okay? Now on this question, they want to know in part A, what's the probability of like number 1 here, never shopped on the internet? These marginal totals are really going to help you. So probability of no, what you're going to do is you're going to look at like, well, 1,200 people said no out of the total 2,000. Okay, and you're going to just use those totals to help you answer parts A and parts B. One that gets a little bit tricky here is when you get down to parts C and D, you need to use some conditional probabilities here. So, or I guess it's still part A, but number 3. Sorry about that. This was like number 1 of part A. All right, so on number 3 here, it says, what's the probability that they have shopped on the internet given that the adult is female? Now that wording, given the adult is female, means on number 3, I am no longer looking at the 2,000. I am only looking at my female data, okay? Because again, the words said given female. Okay, so that probability, the probability that they have shopped on the internet, given, that bar right there is going to be our notation for given, they are female. Now this changes our total, and we're no longer out of 2,000 because I don't care about everybody, I just care about females. So in this problem. Okay, so 800, and then yes, given they are female, I'm going to change that there. Okay. on part B, it's asking mutually exclusive here. So mutually exclusive means they don't have any outcomes in common, and that's gonna be anything that doesn't have any overlap. So if an event is mutually exclusive, okay, that's either we're looking at yes and no, because you can't answer both yes and no. Okay, there's nothing in common between those two columns. Or male and female would also be mutually exclusive in this data. Now on part C, if you want to know female and shocked independent, okay, you're going to actually be able to use what we did in number 3. So you're going to want to look at, is the probability of yes given female the exact same probability of just saying yes? Independence means it shouldn't matter if I am in this row or this row. The proportion of yes should be the same no matter what, and it should match the overall proportion, okay? So if you use 300 out of 800 for that probability of yes given female, oh really, sorry, it actually should go this way. Oops, I'm sorry. 300 out of 800. Okay, for this probability here, is that the same proportionally of just yes out of the total? And that's how you're going to answer independence. Fast forwarding to 4.4, there is a problem that uses this exact same data. So I'm going to keep this data table kind of here at the top of the video. Here, and then I'm going to have us look at some more questions. So this is in section 4.4, question 4.54 uses this exact same data set right here, okay? So in this problem, what they want us to start looking at is some joint probabilities here. And so on the first question, they are asking us what's the probability, okay, that somebody has never shopped on the internet and is male, okay? Never shopped on the internet and is male. So that would be the probability of no and male. No and male. Well, in my problem here, I'm going to just look at the cell. There is only one of these cells that would be both no and male, and that's going to be 700. Now, the 700 in this problem is out of everybody, so the denominator of that fraction is going to stay at 2,000, okay? And then you'll be able to go through and answer all those questions. Part B says, what are all the joint probabilities for this problem? And so you want to look at what are all the possible ands of this, and you're going to want to look right here. Okay, these are all the possible ands in your table. So between A and B together, you should have 4 total probabilities. Little hint for you there, okay? There's another question actually in 4.4 that I want to go over with you, and that's question 4.50. Okay, so sorry to kind of backtrack there. It's just this went with the other table, so it was easy to go over there. So on 4.50, it gives you the following things. It says, given the probability of B is 0.29, and the probability of A and B is 0.24. Find the probability of A given B. Well, the probability of A given B is the equation of the probability of A and B over the probability of B. I want us to go back to that table that we were just looking at here when we found the probability of yes given female, okay? In this example here, when we found the probability of yes given female, we used this equation. We just didn't use it as the equation, okay? This 300 is female and yes, because it's that 300. Out of female is that 800. So we did that here, just not using this official formula, but it's something that we already did in this section, really. So you're just going to use this formula. Oh, sorry, this notation here means and.
Mommy, I got 9 coins.
Okay, that means and. So you're just going to do that division there, but I wanted to make that connection to the 4.3 data table. All right, in section 4.5, the first question that I want us to look at is 4.72. All right, so in this question, they were asked whether or not they actually look at the calories and fat content when they buy groceries. And again, we have this split by men and women. And then yes, no, and then no opinion, which I'm just going to label as no opinion like that. And again, I'm going to copy this table down just so that we have it for reference in the video. And it tells us that the total here was 600. Now, one of the things that I'm going to want to do, again, is find my marginal totals, okay? And so when I add up all the men, I actually get 300, and all the women would be 300. And I always like to check to make sure that adds to 600. And when I add up all the columns, I get 180, 292, and 128. And again, when I add those, I do get 600. All right, on part A, it's asking us what's the probability that you get a Mann outcome or no. Now, Mann or no, if I use this data table, well, if I just add the men up, remember this 300 is the 74, the 168, and the 58 added up together here. If I add up the no's, then that's the addition of 168 and 124. So if I add up this Mann or no, and I do 300 plus 292, the problem is I added 168 twice when I did that. I added it once here and I added it once here, and so I need to subtract out one of those. The other option that you would have is to add 74, 168, 58, and 124. Just like add those 4 cells. But I'm trying to bring in the formula for the OR, which is Mann plus no minus the like and probability. Okay, and so that's what I'm doing here. And then I'm going to divide that by the total of 600. On 476, okay, you're going to have to do that same formula, but they're going to give you it in a word problem, not in a data table. So it might be a little bit tricky to go through and do all of that work. So it says the probability that there is bad weather is 0.25, and the probability that there is an incident is 0.15, and the probability of the and is 0.08. Okay, so there is this possibility that there's bad weather and an incident, which sounds like a very eventful time if that were to happen. So the problem is, again, if you just add, because it wants to know what's the probability of or in this problem, if you just add 25 and 15, you're counting this 8% twice. If you think about this in terms of maybe like a Venn diagram set, 25 is this whole circle of bad weather, and 15 is this whole circle of there being an incident. And again, this 8% is counted twice when you just add 25 and 15. They're not mutually exclusive events. They have an intersection. They have an and. So we're going to want to subtract that out in this problem. Same idea as the problem up here. Again, just the way they gave the data in this question was a little bit tricky. So I wanted to make sure that we went over that one. All right, one more problem to go over in this video is in 4.6. So, and I wanted to show you on the calculator how to do this as well, and which one to do. Okay, so we're going to look at 4.88. All right, so in this problem, it says that they have 9 members, and they need to assign 2 for this patrol unit. To the rescue. Yeah, rescue. Okay. Now, if it doesn't matter the order in which they are picked, that is called a combination. And I just want to know how many different ways can I have 9 people and choose 2 out of them. What that also means is if I choose person 1 and 4, and I choose person 4 and then 1, that's the same combination, okay? It doesn't matter which order and in which I choose them. And so the notation for a combination is we say 9 choose 2. The formula, which they give you in the book, is you do 9 factorial over 2 factorial, 9 minus 2 factorial. Now, 9 factorial, if you do this by hand, is 9 times 8 times 7 times 6, all the way down to 1. 2 factorial is going to just be 2 times 1. 9 minus 2 would be 7 factorial. And so that'd be 7 times 6 times 1. Okay, and you could do all of this in your calculator, but I actually want to show you how to do that here. Okay, and I'm going to show you in the 84, and then I'm also going to show you in the Inspire, okay, because I don't know which one you use. So I'm going to show you both. So if you go under Math, okay, press the Math button, it's directly under Alpha, and go over to Probability, you will see this exact notation here and choose R. Now, when you choose that, okay, you actually need to have already input 9. So we're going to have to do this again, but I just wanted to show you where it was. So you're going to say 9, then you're going to choose that function here and choose R, 2, and press enter, and it gives you 36, which is our answer here. if you use the Inspire, okay, and it takes a little bit, it's a little hard to get it to show up on here. Maybe if I use color behind it instead of white. Let's try. Is that any better? No? Okay. Well, maybe let's do this here. Oh, I need to, maybe I'll do this. That should help. There we go. Sorry about that. Okay, so it's that backlit screen. It's having a hard time. So on the Inspire, you don't have to type in the 9 first. You're going to go under your menu button, probability, and then this is a combination. So you're going to choose combination. And then it pulls up, it is a little bit hard to see here, but it pulls up NCR. You're going to use the notation 9. And then comma, it's down by your O where like pi is. And then 2. You'll see that. Sorry. And then when you press enter, it'll give you the 36. Okay. And so those programs are already in your calculator so that it's doing this formula for you in the calculator. You still have to know which one to use, permutation or combination, but the calculator will do the formula for you, okay? Now, the other thing it says is, now suppose the order of selection matters. So this doesn't count as just one combination. This now counts as 2 separate combinations. When that happens, we're going to do what's called a permutation. So 9 permutation with 2. Now this formula from the book is 9 factorial over 9 minus 2 factorial. That's going to be 9 factorial over 7 factorial. And then 7, 6, 5. But then again, your calculator will do this for you. And then on the 84, it's the same place. So 9, math. Probability, you're just going to use permutations instead. And that gives you 72. On your Inspire, menu, probability, permutation, 9, choose 2. Okay. All right, that about does it for the Chapter 4 homework.